America's freight railroads serve thousands of customers across an interconnected 140,000-mile rail network. With 1.5 million rail cars moving across the system at any given time, railroad operations are highly complex. Today, we'll look at one such operational practice known as reciprocal switching, where one railroad serves a customer on behalf of another railroad. Railroads negotiate reciprocal switching agreements with other railroads on a case-by-case basis where they make economic and operational sense. We're going to start by introducing you to 5 common railroad operations: yard switch, industry switch, connection, interchange, runaround. Then, we will take you through a realistic reciprocal switch scenario that utilizes these operations, some several times over. Before we dive in though, there are a few things you should know about railroad operations. First, railroads only run their trains on their own tracks. They generally do not have access to the tracks of other railroads. Second, locomotives are not like automobiles. They run on fixed track and can only change tracks or direction through a complex set of movements. Third, delivering a rail car to a customer is more complicated than it seems. The car must be pushed into the customer's facility by a locomotive, which requires it to be positioned correctly in the train. Now, let's look at 5 common railroad operations that often occur during a reciprocal switch. A rail car can be part of several different trains as it moves from its origin to its ultimate destination. A yard switch is when railroads move rail cars between tracks or when they add or remove rail cars from a train. This operation takes place in a rail yard where railroads assemble and disassemble trains. Let's take a look at how this happens. A train moves rail cars into a yard. The locomotive removes a car from the train and places it on a track with other rail cars destined for similar locations. The locomotive then returns to its train and leaves the yard. An industry switch is a process by which a railroad moves a rail car into and out of a customer's facility for loading and unloading. Take a look. A train moves to the intersection with the customer's track. The locomotive removes the empty car from its train and places it on the customer's track. Several days later, once the car is loaded, a new train moves to the intersection with the customer's track. The locomotive retrieves the loaded car and adds it into its train. The train then leaves with the loaded car. Trains can't change tracks without special infrastructure. A connection is a piece of track with a switch at both ends that allows a train to move from one track to another. Let's see how it works. A train moves from one track through a connection onto a new segment of track. An interchange is an operation that allows 2 railroads to exchange rail cars. Here's how it works. Green Railroad's train approaches an interchange track and separates the car to be handed over to Blue Railroad. Green Railroad's locomotive places the car on the interchange track. Blue Railroad's locomotive retrieves the car from the interchange track and adds it into its train. Blue Railroad's train leaves the interchange. A runaround is an operation that allows a locomotive to move from the front of the train to the rear, allowing the train to switch directions. Let's see this in action for a southbound train. The southbound train moves into a passing siding. The locomotive detaches and exits the south end of the siding. It then reverses direction and runs up the main line to the north end of the siding. The locomotive reverses direction again and moves into the north end of the siding where it connects to the opposite end of the train. The train can now move northbound. Got all that? Good. Now we'll see how these operations are used to complete a reciprocal switch between Green Railroad and Blue Railroad. Due to the schedules of the many trains required to perform the operation, this scenario can take 6 days or more to complete. What follows is a simplified illustration which does not take into account real-world conditions. Here, the shipper, XYZ Corporation, wants to ship 1 carload of plastic pallets from its facility to customer ABC. XYZ is located on Blue Railroad's network but wishes to ship its pellets on Green Railroad's network. So, for a fee, Blue Railroad has agreed to move Green Railroad's railcars to and from XYZ Corporation. As you will see, this scenario requires 8 different trains, 3 rail yards, 3 sidings, 1 connection, and an interchange track. The scenario begins when XYZ Corporation requests a railcar from Green Railroad, the railroad whose network it negotiated to ship on. At its yard, Green Railroad uses a yard switch to incorporate XYZ's empty car into Green Train 1. Green Train 1 moves the XYZ empty car from the Green Railroad yard to an interchange track, where Green Railroad and Blue Railroad exchange the car using an interchange. Blue Railroad now has possession of Green Railroad's XYZ car and moves it north to Blue Yard East. At Blue Yard East, a yard switch is performed and XYZ car is added to Blue Train 2, whose destination is Blue Yard West. The XYZ car must go to Blue Yard West because it is the yard that serves the XYZ Corporation's facility. Blue Train 2 moves the XYZ car via a connection to Blue Yard West. Here, a yard switch adds the XYZ car to Blue Train 3, the train serving the XYZ Corporation's facility. The runaround depicted is necessary to position the XYZ car so it can be pushed into the XYZ facilities track by the train's locomotive. These operations generally take place in rail yards to minimize disruption and congestion on the railroad's main track. The train moves the empty car eastward towards the XYZ Corporation's facility. Before delivering the empty rail car, the train must remove a loaded rail car that sits in XYZ's tracks. Then, using both a runaround and an industry switch, the empty car is delivered onto XYZ's tracks. Several days later, once the empty car has been loaded, Blue Train 4 uses an industry switch to retrieve the car from XYZ's tracks. With the loaded XYZ car in hand, Blue Train 4 begins to retrace its steps by moving the XYZ car back to Blue Yard West. In Blue Yard West, a yard switch adds the XYZ car to Blue Train 5, which serves Blue Yard East. Blue Train 5 utilizes a connection to access Blue Yard East, the yard that services the interchange with Green Railroad. At Blue Yard East, a yard switch adds the loaded car to Blue Train 6, which serves the interchange of Blue Railroad and Green Railroad. Blue Train 6 moves the loaded XYZ car to the passing siding, where the locomotive performs a runaround. This operation is required to position the XYZ car on the interchange track. The train, now moving northbound, arrives at a clearance point beyond the interchange. Blue Railroad and Green Railroad exchange the car through an interchange. At this point, the XYZ car is now in the possession of Green Railroad and can begin its journey to the customer. Green Railroad's Train 2 performs a runaround and moves the loaded XYZ car back to its yard. Finally, a yard switch will incorporate the XYZ car into a train destined for ABC customers' facility. This is an example of a typical single-car reciprocal switch. As you saw, it required 68 operations and would have taken about 6 days to complete. What you didn't see in this scenario were the additional actions by railroad employees that would be required when cars are added to trains, such as connecting air brakes and conducting safety inspections. Delays associated with train schedules, track maintenance, and other rail operations also have the potential to increase the time needed to perform this reciprocal switch. While there are circumstances where reciprocal switching makes sense, it is not usually the most efficient way for railroads to provide service to their customers, as it is complex, costly, and time-consuming. Thanks for joining us today to learn about reciprocal switching. To learn more, please visit our website at www.aar.org.